Okay, guys, so I'm going to be showing you guys the Desmos. You guys are going to be completing everything on your computer. Not on your computer, on your packet. So first thing I want you guys to do, this one is going to be on this slide of the Desmos is not in your packet. Um, so I'm going to show you guys this video. And then in the Nearpod, you're going to tell me what is some kind of question I could ask you about this video? A mathematical question. What are some mathematical questions I can ask you based off this video? Okay. Okay. So think about what you noticed in that video. Um, think about what was going in, what the total was, all of that. What kind of mathematical questions could I ask you about this video? Okay, slide two. So this is the start of your packet. We're going to be talking about the total of that video was $62, and the only thing that was put into it was pennies and quarters. So we're going to figure out how many pennies and how many quarters could have gone into it. Um, Something that is important to think about is how much each penny and each quarter is worth. So our pennies, number of pennies and number of quarters are not going to add up to 62 coins because pennies are worth a lot less than a dollar and quarters are worth a lot less than a dollar. Um, let me annotate. So if we think about it, pennies are worth 0.01. Whoa, 0.01. And quarters are worth 0.25 of a dollar. And we want them to add up to $62. So I always like to start with zeros. Zeros of each are just a great way to start thinking about and figuring stuff out. So if I had 0 pennies, how many quarters would add up to $62? Well, if we know that quarters are worth 0.25 of a dollar, we know how many quarters would be in a dollar. And there are 4 quarters in a dollar. So 4 quarters times $62 is going to be $62 times 4 quarters, 248. So if all $62 was in quarters, that would be 248 quarters. But we could also check, what about if there was 0 quarters? Well, we know that pennies are only 1 cent or 1/100th of a dollar. And we know that there are 100 pennies per dollar. 100 pennies in a dollar. So if all $62 were in pennies, there'd be 100 pennies times $62. That's 6,200 pennies. So if all of it was in just pennies, then there'd be 6,200 pennies. It's a lot of coins, but in just pennies, that is $62. Okay, and now our other one, we've already used up our zeros, so now we can basically kind of pick out whatever we want. So let's say that out of the $62, let's say two of those dollars were in pennies. Okay, and again, I'm just picking something random. Um, It doesn't have to be exact or like there's no like specific exact thing. I just couldn't do something like 1 penny and then some number of quarters because one penny would be 1 cent, and this is an even dollar amount. But I can start with figuring out, let's say, if two of those $62 were pennies, $2 would be 200 pennies. And then I could figure out what my remaining $60 would be in quarters. So $60 times 4 quarters would be 240 quarters. So if I had 200 pennies and then 240 quarters, that would add up to $62. So if I click check my work, it's going to plot those points for me. Okay. I want you guys to notice kind of what's happening here. Okay. In the Nearpod, I want you guys to come up with a fourth one. What is a fourth combination of pennies and quarters that would add up to $62? It could be anything you want, as long as it adds up to $62 exactly. So any combination of pennies, any combination of quarters that add up to $62. Okay. So now it says describe how you can tell if a combination of pennies and quarters is worth $62. So I'm going to give you guys an example in the Nearpod. It's going to be a multiple choice, and I want you to select which one is worth $62. And then on this Desmos, I want you to describe how you can tell if a combination of pennies and quarters is worth $62. Okay, so in a second here, a multiple choice problem will pop up. You'll have four different combinations. Only one of them will be $62. And then tell me how you can figure out that that one is $62. Okay, so part of it is if you are just given the combinations like we did yesterday with the Takis and the gummies, would want to multiply the number of pennies by that 0.01 of a dollar. So if I had, let's just say 500 pennies, I can multiply that by 0.01, that is $5. And then um, if I had, just for a random example, 234 quarters, and a quarter is worth 25 cents or 0.25 of a dollar, that would be $58.50. Okay, so if I had 500 pennies and 234 quarters, and I added up those amounts, $5 worth of pennies and $58.5 worth of quarters, that is not $62. Okay. So now it wants us to write an equation that describes all of the combinations, and this goes into that standard form equation. So we have our total. Our total is $62. And then we have our unit rates, which doesn't really technically explain, but if we go back to the couple of slides where I typed in here the 0.01, stop typing. Why did it stop typing? And I typed in the 0.25. This is me saying that a penny is worth $0.01. Each quarter is worth 0.25. So those are technically my unit rates. Okay. So for our equation, going back, no, too far. For our equation, it would be 0.01 times the number of pennies because it wants us to use P for pennies. So each penny is worth $0.01. Ignore that dot on here. I don't know what that dot is. I don't know where that dot came from. Um, plus our quarters are worth 0.25 times Q. Q is our quarters. So it's 25 cents per quarter equals our total of $62. And notice that that equation drew a line through all of the points. That equation drew a line through all of the points. Okay, so here is our line, here is our equation, and then we also have point A on the graph, point D on the graph, and B and C on the graph. So it says select all the points that are solutions to the equation. So if we're looking at a graph, if I was to give you just this graph, the equation, your solutions, like we said yesterday, are the points that are actually on the line. B and C would not be solutions. 4,000 pennies is $40. Okay, 2,000 pennies and 200.8 quarters is just over $62. Okay. So your solutions are the points that are actually on the line. So A and D are your solutions because they are actually on the line. Okay. So this says if there are 200 quarters, how many pennies do you need for $62? So if there were 200 quarters, we know 200 quarters times 0.25 of a dollar, that's $50. 200 quarters is worth $50 because each quarter is worth 25 cents. So it's asking how many pennies would I need? Well, I want $62 total. So I need to subtract how many of my quarters, how much my quarters are worth. My quarters are worth $50, so I did $62 minus 50. That means I have $12 worth of quarters. Sorry, $12 worth of pennies. $12 worth of pennies times 1 cent per penny. Mm, I'm sorry, hold on. Let me not times 1 cent per penny. Not times 1 cent per penny because um that's not saying how many pennies we have. This is saying how many dollars we have. So we have $12 and we know that there are 100 pennies per dollar. So 12 times 100 pennies, that is 1,200 pennies. And notice when I made that mistake in my calculator, when I did 12 times the amount of like what pennies are worth, and it gave me this 0.12, I realized my mistake because that doesn't make sense for the problem. My question asked me how many pennies I had. It doesn't make sense to have 0.12 of a penny. Okay. So that is where I kind of caught my mistake was the answer I got did not make sense for the problem. So don't just rely on, oh, these are my steps, so here's my answer. Think about what it actually means for the problem. I've noticed on some previous tests and quizzes that this my students have taken, like that you guys are have taken. There are some of you who just kind of put answers in, and your answers don't make sense for the problem. So think about what it is saying. When I click submit, let me redo it so you guys can see the graph. When I hit submit, it goes over and up so that you can actually see that that point, the point of 1,200 pennies and 200 quarters is on the line. Okay. This part here, you guys can um skip this part on your worksheet because I'm going to skip this part of the Desmos. Okay? So here we have two different situations. You have these two situations on your worksheet. And we are going to, on my screen, my next screen, it's going to be a card sort. on your paper, you kind of have kind of the images that will be in my card sort, and you're going to tell me which one goes into which situation. Give me 1 second because I'm going to tell my dad to turn off this music. Y'all, I don't know what to do with my dad. What? Is it okay with the door closed? It's better, I said. Oh my goodness. I'm so sorry, guys, for the disruption. Okay. So here's our two situations. Situation one, Sydney plans to buy 120 beverages for a picnic. Seltzers are sold in packs of 6. Waters are sold in packs of 8. X represents the number of seltzers, Y represents the packs of waters. Okay? So in this situation one, we have a total of 120 beverages and we have two unit rates. We have $6, or sorry, not $6, 6 seltzers per pack, and we have 8 waters per pack. Situation two, a coach has a $120 budget to buy lunch for his team. They are ordering from a restaurant that charges $8 per sandwich plus a $6 delivery fee. X represents the number of sandwiches and Y represents the total cost of lunch. So here Y is representing the total. Y is representing the total. So yes, this gives us our total that the coach has to buy lunch. But he could spend less than that. So this equation is actually giving us, or this situation is actually giving us one unit rate, that $8 per sandwich, plus a $6 delivery fee. That $6 delivery fee is a one-time fee. That is a starting amount. So this $6 delivery fee is actually our starting amount, where Y is our total. Okay, so because that 120 is in there, that is in there to kind of trick you guys. But also pay attention to what your X and Y's represent. So in situation one, X represents numbers of seltzers per pack, or the number of, well, I guess it's number of packs of seltzers, where we know 6 is seltzers per pack. Y represents the number of waters, and there's 8 waters per pack. Whereas situation two, X represents the number of sandwiches. We know it's $8 per sandwich. Y represents the total cost. Okay? So total cost is that 120 as the maximum. So moving here, so again, mine looks like a card sort. Yours is on your worksheet. So you have the two equations. Oh, I don't like the way they did this equations. Okay, there's the other equation. 3 equations, 2 points. We have a graph and we have a table. Okay, so let's start with A. A, we can see X is going up by 2, 3 to 4. So in situation one, that would be saying 2 packs of seltzers, 3 packs of seltzers, 4 packs of seltzers. Our Y's are going up 22, 30, 38. This is saying 22 packs of water, 30 packs of water, and 38 packs of water. If I had the 30 packs of water, let's look at this second second row here. 3 packs of seltzers, 30 packs of water. There are 8 waters per pack. So 30 packs of water times 8 waters per pack, that's 240 waters. That is already over the amount that she has available. So just to double check it with situation two is $8 per sandwich plus $6 delivery fee. So if I'm looking at my 2 and 22, If I did $8 per sandwich, 2 times 8 is 16, plus $6 delivery fee, 16 plus 6 is 22. I can double check it with 3. 3 times $8 per sandwich. 3 times 8 is 24. 24 plus 6 is 30. So this A belongs to situation 2. I'm going to just jump to the graph now, instead of going to B, because I want to talk about the equations separately. So with our graph, we can kind of take the slope and y-intercept. Only one of these equations is a slope and a y-intercept. The other one is in that kind of standard form. So this has a y-intercept of 15 because it hits the y-axis at 15 here. Neither of these situations talks about a starting amount or an initial fee of 15. So this is not our equation with the slope and y-intercept. So start like thinking about that. This is not the situation that is the slope and y-intercept. This would be for the standard form situation. Which of these situations is standard form? Which one of these do you think C belongs to? Answer this one in here, Proud. Okay. So if we just think about this y-intercept point, 0, comma 15. So for situation 1, that'd be 0 packs of seltzers, 15 packs of waters. So 0 seltzers means it would be all waters, and there's 8 waters per pack. So 15 times 8, if we did 15 times 8 in the calculator, which, give me a second, 15 times 8 in the calculator is that 120. So this does work for situation 1. If I tried it for situation 2, I have $8 per sandwich plus a $6 delivery fee. 0 is my X. So if I had 0 sandwiches plus a $6 delivery fee, that's not $15. So this matches up with situation 1. Okay. I want to do these equations with you guys. There are 3 equations here. Only one of them belongs to each. Because it says here one card has no match. So I've kind of talked about situation 1 is that standard form equation. Only one of these is standard form, but I want to talk about it. We have 120 beverages is what she's buying. So that's our total of 120. And they just put the C in front instead of on the back, where I told you guys it's AX plus BY equals C. They just did C equals AX plus BY. So we have 120 equals 6 seltzers per pack of seltzers plus 8 waters per pack of waters. So this goes with that situation 1 that is standard form. Situation 2, we have $8 per sandwich plus a $6 delivery fee. So you need to know which one is your slope and which one is your y-intercept. So your slope is that unit rate, $8 per sandwich. Your y-intercept is the starting amount or the initial fee. So these ones here are kind of written to kind of trick you. Is that the 120 or is that the $6? 120 is the total amount that she has able to buy. $6 is that initial fee. So it's actually this y equals 8x plus 6. And we can put 120 in for y to see how many sandwiches she could buy. Okay? So that 120 has nothing to do with the equation or the graph or the tables. That 120 is kind of like the end amount. It's like the amount that she has to stop at when trying to figure out how many sandwiches to buy. So this one up here, E, does not belong to either of them. I want you guys to try to figure out F and G on your own. So think about 5 being X, 46 being Y. Does it make sense for you to have 5 packs of waters and 46 packs of seltzers? Sorry, other way around. X is seltzers. 5 packs of seltzers and 46 packs of waters? Or with the 8 and the 9, does it make sense for there to be 8 packs of seltzers and 9 packs of waters? So use these 2 points to figure out which one goes to situation 1 and which one goes to situation 2. Okay, so describe how you could use the graph or equation to determine whether a point is a solution. So if I said the point 2 comma 6, the point 2 comma 6, how could you determine using either the graph or the equation whether the point 2 comma 6 is a solution? Answer that in on your paper in the synthesis section. And then I don't think you guys have this problem. Oops. I don't think you guys have this problem on your worksheet, so go ahead and answer it in the Nearpod. The graph of a linear equation includes the points negative 2 comma 0 and 0, 6. Could this equation be an equation for this line? Use the graph if it helps your thinking. You don't have a graph, but basically what this is saying is I'm giving you a graph that has the points negative 2 comma 0 and 0 comma 6. So we're looking for a line that goes through these points here. And then it's asking, would this equation work? So use the equation for each point. Would the point negative 2 comma 0 work for this equation? Would 0 comma 6 work for this equation? Answer it on your Nearpod. Yes, no, there's not enough explanation or not enough information. Okay, if you are one of my friends that is stuck and doesn't know how to figure this out still, if you're taking these points and putting them into the equation, you're solving to see if it works. So my first point, negative 2 comma 0, negative 2 is going to go in for x, 0 is going to go in for y. So if my equation is 3x minus 6, sorry, not minus 6, minus y equals negative 6. And I put negative 2 in for x, that'd be 3 times negative 2 minus my y is 0, so minus 0. Does that equal negative 6? Well, 3 times negative 2 is negative 6. Minus 0, does that equal negative 6? Yes, negative 6 minus 0 does equal negative 6. So this does work. The other point, if this other point works, then yes, this equation would be an equation for the line. So my other point is 0 comma 6. So again, my equation 3x minus y does equal negative 6. So my x is 0, so that would be 3 times 0 minus my y is 6, so minus 6. Does that equal negative 6? 3 times 0 is 0, minus 6. Does that equal negative 6? Yes, 0 minus 6 is negative 6, so that does work. Since both of these points work for the equation and makes the equation true, they are both solutions to the equation. That means that this equation is the line. So if you said yes, you are correct. Okay? On the next slide of the Nearpod, you are going to tell me how well you understood this lesson today. If you guys have any questions, please reach out and make sure you guys are studying for your tests next week over the weekend. Monday, your work is going to be a review. for the test, and then Tuesday you guys are going to have the test. So please, please, please make sure you are studying. Again, if you have any questions, please reach out, send me an email, send me a message on Google Classroom, anything.